welcome to lecture number 18, and in our last lecture, as you know, I told you how to translate an inductor with initial current into a linear inductor in parallel with a current source, and similarly a charged capacitor initially can be also translated into an uncharged capacitor in series with a voltage source like this A and B. You have to invoke a battery. So, another two sources will be introduced and we will solve several problems in tutorial, and I will also ask you to solve several problems using this concept. Now, today what I will be doing is, see, while solving these circuit problems, say RL circuit, RC circuit, discharging or charging circuit of both RL and RC type, essentially what we are doing is we are writing down the differential equation and trying to solve that differential equation. Fortunately, the differential equations with constant value of RL and C will always give rise to a linear differential equation. And also I told you, and we have seen that if in a circuit there is only one energy storing element is present, for example, RL circuit, okay, and we have studied this, and you have a battery like that E, and switch is closed at t equal to 0. Then I can solve for the current. How did I solve this current? I wrote down the KVL equation, which was equal to L di dt plus R I, and I divided both sides by L to get this R by L into I is equal to E by L. So, it was a differential equation which is first order differential equation, first order, because only d dt is present, no d 2 dt 2 is present. So, first order differential equation, first order differential equation. And then I multiplied with the integrating factor, then integrated, got the value of I in my previous lecture, similar with the capacitive circuit. Now, I will digress a bit from the circuit and try to tell you today that okay, it is essentially in a circuit when currents will be functions of time, etc., and energy storing elements will be present, then it is bound to give rise to a differential equation, linear differential equations. The question is, can I avoid those steps of multiplying with integrating factor and then get the solution, or is it possible also to find out the solution, that is I t, the solution I t, whether can it be written just by inspection. I will have this differential equation, can I write the solution in one stroke without every time multiplying with integrating factor and so on. That is the whole idea. That will also give us a better insight into the problem. Therefore, today and maybe in the next lecture also, I will concentrate on how to handle linear differential equations. Given the linear differential equations, how to write down the solution of that differential equation just by inspection without spending too much time on integrating factor this that. That is the whole idea. So, first let us then take a differential. So, solving a linear differential equation, So, take a general differential equation like this: dy dt plus say a y is equal to x t, where x t is called the forcing function, which may be a function of time or it may be constant, what not, it may be anything. Except x t, I ruled out this possibility, is not equal to an impulse function. We will talk about this later. X t is a general reasonable function, it can be anything. Now, what will be the solution of this? A is constant, and we are looking for this solution. Y t is how much? X t is given and maybe some boundary condition is given. It is a first order differential equation. So, one boundary condition will be needed, that is y 0 or y 0 minus, from which I will get y 0. Same, if it is inductor current, y 0 minus is y 0 plus y 0, similarly capacitor voltage. Okay. So, this is the statement of the problem. This differential equation I have to solve. Okay, here of course, I will use that fundamental thing, that is I will multiply both sides with the integrating factor e to the power a t. Very simple stuff, but very educative. A into e to the power a t into y is equal to e to the power a t into x t. X t could be a function of time, as I told you. So, this is the thing. Then or we can write d dt of this is product of two function we have done several times before, y is equal to e to the power a t x t into dt. No dt, this is this will be the thing. Now, then we say that d of dt you bring it to this side. So, that you can say it is equal to e to the power a t into y is equal to e to the power a t x t dt. This is the thing. Now, this one, let me go to next page and write this d into e to the power a t into y is equal to what? E to the power a t into x t, e to the power a t into x t. X t is the input, forcing function, into dt. My target is to get y. So, I will integrate both the sides. I will integrate. The moment you integrate, you generate a integrating constant a. Then left hand side will be e to the power a t into y is equal to this integration, which can be also written like this, e to the power a t dt plus a. I am not putting any limits, that is why this integrating constant has surfaced a. Okay. So, this is the thing, or I will say y t will be multiply both sides with e to the power minus a t, then this integration x t e to the power a t into dt plus of a into e to the power minus a t. This is the thing. Now, what we will be doing is that this integration, if you look at, this is fine some term, but here is an integration which is product of two functions. So, this integration I will expand. So, e to the power minus a t was there already. So, what I will do is this, I will apply the rule of integration of product. So, first function, that is x t, into integrate this I treat as first function, and this e to the power a t as second function. So, first function into integration of the second, which will be this by this, then minus of integration of differentiation of first function, that is dx dt, into integration of the second, e to the power a t by a. This will be this term, but for dx dt what I will do, I will write x dot. Okay. X dot is dx dt. So, differentiation of the first function, that is x dot, into integration of the second, e to the power a t by a. A is a constant number into dt, and plus of a into e to the power minus a t. This will be the thing. So, the solution will then look like 1 over a, put this e to the power minus a t inside. So, this will cancel out, it will be x minus e to the power minus a t, it comes before this integration, and then this integration x dot into e to the power a t, and this 1 by a can come outside this integral. So, this I have written into dt and plus this term. A is that integrating constant we have already written. So, this will be the thing, clear. So, you used the product of integration property, first function integration of the second minus differentiation of the first function, that is x dot dx dt, it is e to the power a t by a and so on. So, this is the thing. Now, in this step once again I find that okay, this term is fine, 1 over a into x minus e to the power minus a t by a, that is also fine, but here is once again product of two functions and it is to be integrated. So, I will apply once again the product rules of integration and expand this term and try to see what do I get. For example, I will say this is now my first function and this is second function. So, I will say first function, that is x dot, into integration of the second, e to the power a t by a, minus integration of differentiation of the first function, that is d 2 x dt 2, which I will write x double dot, into integration of the second, that is e to the power a t by a into dt, that is all. And then of course, this term is always there, a into e to the power minus a t, is not, this will be the thing. So, once again open this bracket and you will be getting it as 1 over a x minus this e to the power minus a t to the power a t will go and you will be left with 1 over a square into x dot, then plus of this minus plus and you will be left with e to the power minus a t by a before this integration, e to the power minus a t by a, and this a will also come out, make it a square, and you will be left with x double dot into e to the power a t dt, and plus of course this term e to the power minus a t. This you will get. Okay. Now, once again I have not really I have got the solution, but this integration once again appears x double dot. I will do once more. Okay. So, I will say, and this time I will do very quickly. This is once again this first function, second function, I expand that. So, what it will be 1 by x minus 1 by a square x dot, then plus of e to the power minus a t by, let me do one step, please bear with me, I am doing some mundane thing, but it is very useful when I finally draw the conclusion. You see how nice it is. So, it will be, then once again you integrate it by parts, then it will be differentiation of x double dot. So, it will give you x triple dot, first function differentiation into integration of this second, that is this by a, first function, that is x double dot into integration of the second minus integration of differentiation of the first function, that is x triple dot into integration of the second. dt, is not, it will give like that, integrating by parts, going on. I mean, first step I did, then once again I expanded this, now I am expanding this, and this is this, and this is plus a into e to the power minus a t. Now, this is equal to your y t. What I will do is this, I will copy this last step. Copy this here, where is the copy? Here, copy, go to next page and paste it. Okay. So, this is the equation last I got. Okay. Only thing here that I forgot to copy this, minus a t it was there, other things are correct, I got this. Now, this if you expand, it comes out to be 1 by a x minus 1 by a square into x dot. Then if you put it inside, it will be plus 1 over a cube into x double dot, this e to the power a t cancels out, minus e to the power minus a t by a cube, because a square and this a, and this is the integration of x triple dot into e to the power a t dt, and then plus finally this one. Okay, I have now understood what is going to happen if I further expand, is not, but nonetheless the solution looks like if you go on expanding this, it will be like this, some constant, this is important, x plus another constant into x dot plus another constant let me write it k 0 x, k 1 x dot plus k 2 x double dot. Similarly, if you proceed like that, it will give rise to x triple dot, and it looks like it will go forever up to infinity. Go on splitting this one and you will get like that, but nonetheless up to infinity, infinite terms plus a into e to the power minus a t. That will be the solution of what? Of this differential equation dy dt plus a y is equal to x t. What is x t? X t is the forcing function. Got the point. So, this is the solution. Now, in language, if you look at this one, you will see that this solution has got two parts. One part depends on the input and its higher order derivatives up to infinity, plus another term which does not depend on input signal x t, but it depends on the system characteristics R by L, for example, in case of RL circuit, that system this A is system constant. So, this part of the solution I can say that the solution y t will comprise of two parts. One is except t, x t is the forcing function, that is, and another part which depends upon only system constant, and that is called natural response. I will write it as x and t. So, every differential equation, whether it is first order or second order, we will extend this result to second order as well. Do not worry about that. At least for the first order system, I can very confidently say, logically thinking that okay, this is the differential equation, it is a forcing function, it could be anything, any function of time, maybe a sinusoidally varying function of time, maybe some pulse, what not, whose equation is known, or maybe a constant number, as in case of an RL circuit excited with a DC voltage right hand side is a constant. But whatever it is, the first part of the solution is called solution due to forcing function, due to forcing function, that is x t. It depends on that only, x t and its derivatives up to infinity. That looks like a daunting task, but we will see how simple it will become. And this part of the solution is called solution due to natural response. Solution natural response, let us write like that. Natural response or response of the circuit with no, I am so sorry, I should write it in this way. This solution has got two parts, y f t plus y n t, because I am looking for y na. So, y f t is solution due to forcing function, y n t is the natural response when x t is 0. So, what is natural response? It is response of the system when x t equal to 0. Put x 0, all are zeros, a to the power minus a t, is not. That is response of the system when x t equal to 0, that is, this is the solution of the system when dy dt from this equation plus a y is equal to 0. No input is given, what is the solution? Can there be a solution without input? Yes, because a differential equation means, so far you are doing circuit analysis, you can easily correlate it. Oh, there was either some inductor or capacitor was present, and that might have some initial stored energy. So, you can get always solution because of that. Or in physical system mechanics, say mass spring system. So, if mass is present, even without any excitation, there may be movement because of initial kinetic energy of the mass, although external force applied is 0. So, this is the thing, mind you. So, the goal is that differential equation we are somewhat solving mechanically, that is differential equation is there, find out the integrating constant. Each time I did in my previous lecture while solving RL circuit transient or RC circuit, I wrote the equation, I multiplied with integrating factor, solved it, put boundary conditions, got the solution, nothing wrong in that. But what I am now trying to tell you, you now think physically, solution, now I identify that the total solution of the system has got distinctly two pieces. One piece depends on the forcing function on the right hand side, and the other part is natural response when x t is 0. And when x t is 0, natural response will be like this. That is what we have found. Got the point? Now, when I say that this is the solution of this is the solution of what? So, differential equation, although, so original differential equation, very interesting, I am telling you, if you please follow me, dy dt plus a y is equal to x t. This is my original differential equation, and we have got this total solution. Now, two observations. Obviously, this, if you claim this is the solution, so if I substitute this here, it must satisfy this equation. Solution means that whatever solution you have got, if you put it here, it will satisfy that. First thing is, therefore, I will expect that d dt, let me put this as y f plus y n plus a of y f plus y n, and this must give rise to x t, is not. Now, this I will write it as d dt of y f plus a y f plus d y n by dt plus a y n, and that will be, has to be x t, is not. But the solution due to natural response, we have found out earlier, this y n t is this one, a into e to the power minus a t, a into e to the power minus a t. So, what will be this, if you substitute here, what is this addition? It will be equal to dy n dt, that is minus a into a e to the power minus a t plus a into y n a into e to the power minus a t, and it will give rise to 0. Getting? Therefore, the natural part of the solution, I am substituting the full solution. I find that y n part will give rise to 0, and therefore, I will say, I will not go to next page, because this is so important a conclusion. Then I will say from this to this that let me use some other color. I will say that it will be equal to d y f dt plus a y f plus this has to be 0, these two terms is equal to x t excitation. So, the conclusion of this statement of this equation is this: solution consists of two parts, natural parts which does not depend upon excitation, and natural part if you substitute on the left hand side will always give rise to 0. And I find that the part, the piece which I am saying is the solution due to forcing function alone will also satisfy the differential equation. This is the statement, that is y f plus y n satisfies the differential equation, it has to is equal to 0. Also d y f dt plus it is obvious from this a y f will also satisfy this. This is crucial to understand. D dt of y f plus y n plus a into y f plus y n is equal to x t. So, y f plus y n satisfies the differential equation. So, also forcing function alone, solution due to forcing function y f t alone will also satisfy the differential equation. Now, what is the then in which way it is going to help me? I will stop here. Before that, I will tell you one thing. See, for example, let me take an example, so that you keep your interest alive in this particular topic, because at the end things are so simple. For example, you have a differential equation dy dt plus 2 y is equal to say what t square. This is my x t. I have to solve this differential equation, and the boundary condition is given y 0 is equal to suppose 2. Solve for y t. That is what I have been told. Now, I know I will write down in one stroke. I am not going to use now any integration like that. I identify x t, then y total solution y t will be what this 2 comes in as a into e to the power minus 2 t, that is what we have seen, this term will be there. Then there will be, so this is the natural response, straight, I mean no further thinking, straight away I will write, oh, this is the thing, a e to the power minus 2 t, a value is equal to 2 in this particular case, this term is natural response. Then plus the solution due to forcing function, this I am putting a bracket. That solution I know it will be proportional to k 1 into x, x t is equal to t square. So, k 1 into t square plus x dot into some k 2 bar into x dot. What is x dot? 2 t, 2 t. So, 2 into t, and this 2 I will absorb it in this constant. So, k 2 into t plus, because I have to go up to infinity, plus k 3 into x double dot, which is equal to 2 d 2 x dt 2. So, k 3 into 2, k 3 bar into 2 is k 3 plus k 4 into x triple dot. Oh, that is 0, then k 5 into 0. So, although it looked a formidable task, in general whatever functions will be present on the right hand side, it vanishes. So, all the terms I have taken into account, only these two terms are present. Got the point? That is all. That is the total solution. So, differential equation is given. The nature of solution of this equation I will write in one stroke, no wastage of time. I know this constant, this is the natural response, this is this one. That is the thing. Now, the big question is how to find out these constants A, k 1, k 2 and k 3. So, here it ends here. So, people say that given a differential equation, I will carry on with this in the next class, but the crux of the matter is, if you are given a differential equation dy dt plus some constant into y is equal to some x t, we say that solution, total solution will be a linear combination of the forcing function and its higher order derivatives, that is k 1 x plus, you understand the term linear combination, that means k 1 into x plus k 2 into x dot plus k 3 into x double dot, these are constants up to infinity, of course, do not forget to write that, and plus solution due to forcing function, and that will be equal to e to the power minus a t. This is the thing I wanted to tell you, and I will also discuss in the next class is there any exception to this rule, I will discuss, and then I will also try to solve higher order differential equations. So, please go through this lecture, it is interesting. It is not, now I am not integrating, after I obtain this pattern, I know what is waiting for me for y t, and this can be easily written, linear combination of x and its higher order derivatives, these terms. Of course, up to infinity it may slightly disturb you, but in almost all the cases you will find this is not too tough to tackle. For example, t square, t square, t and then t, then constant, after that all differentiation should be 0. So, linear combination of the forcing function and its higher order derivatives is responsible for this solution due to forcing function, this part, and natural response is of course is a system property which is decided by this fellow, which is minus a t, whatever coefficient is there, some constant into e to the power minus a t. Now, at the end, therefore, the solution can be written in one stroke straight. Only thing is you have to put numbers, what will be the values of k 1, k 2, k 3 and a. Those things I will discuss in the next class, and we will use the boundary conditions and some conditions of identity to determine these constants k and a. Thank you.